Okay. So for today's session, where do you think we can start? You guys are comfortable joining two datasets?
Yes, sir.
Okay.
At least the one which we tried, like
Okay.
what you said.
Okay. Do you want to try one more so that things will get clear? Or we can go ahead with something else. I thought I'll introduce you to R Markdown, but we can uh, do that at after half an hour or 1 hour. Before that, we can actually do one more exercise if you guys want, if that will help you.
Yes.
Will be good, like anything little different
Okay.
from what we did, or like that.
Okay. Okay.
Similar.
Sure. Yeah. Can you guys propose one data set?
I was working on NFHS 5 data, so it had all that Ladakh and all those things, so latest
Okay.
data it
Okay.
was.
Okay. Okay. So let me share my screen. Is my screen visible?
Yes.
Yes, sir. It's blank.
Yeah.
It's white.
I don't want to use just the same source of data again and again, but just have a look at what all data is available. Within this data set, this is 10-year worth of data state-wise. Let us have a look at this. This is not really data. Just bear with me. So this is, we have data on annual health survey. You guys are aware of this data set?
Yes.
So basically, you have 283 Excels, okay, of each of the district. 283 this Excels. Let us open one and see in this data set. Non-commercial academic. This is opening a CSV. Okay. This is for the state of Rajasthan in Sihori district in rural block. This is the street term. This is the house ID, household number, yeah, house unit, household number, date of the survey. What is the salt iodine content in that household? Okay, what is the record number? Serial number, gender, male or female, is he or she a usual resident? What is the age? Age is in year. How much is the age? What is the date of birth, month of birth, year of birth? Weight measured. Okay, you have quite a bit of data, no? Hemoglobin, length, height, whatever. Yeah, we have quite a bit of data. Just 1 second. Hello? Hello? Yeah, sorry. So, I'm assuming that we will take one Excel, I mean CSV that they were downloaded. We'll do some cleaning and things like that, and then we'll take one more, a couple of more Excels, and then see if we can reuse the codes that we have used in one for the other. Is that making sense?
Yes, sir.
Yes.
Yes.
Okay. In that case, let us start. What was it? So I'll use the previously used session. Okay. So what I'll take help is from you guys. What should I do now? What is step 0?
Create a project
Right
form.
now.
Okay. So yeah, this first we need to ensure that all the data is in the place where it's called data, right?
Yes.
So as of right now, okay, this is where we can put the data in. I'll ask it to show this folder in a new window. And I have just downloaded the data in a downloads folder that is here, right? This is the data, isn't it? AHSCAB Rajasthan Sihori, correct?
Yes.
Yes.
Okay, so what I'll be doing is this 1 second. I'll just copy this and put it here for now. I'll ask you to try again, and I'll have to close the Excel and then try again. Okay, now it is done. Okay, AHSCAB, whatever. Right now, I can just open a script window and I can say, looking at annual health survey data for the clinical Okay. Now I
Yes.
should actually give the link to the survey and all of that, right?
Yes.
So that will be I'll be able to come back to this, isn't it? So what I can do is I can just copy this link. And then I'll just, there is some additional information. I'll copy this link as well. Just put it here. Sorry. Okay, this is where I got the data from. I'll fill in everything else later on. First, I'll have to load the packages, right?
Yes, sir.
Library,
And here.
Yes, sir. And here.
tidyverse. You cannot hear me, is it?
Yes.
Yes, sir. We can hear.
Okay. Library here, isn't it?
Yes.
Right now, only 2 packages will do. Okay.
Okay.
So how to load the data?
No data.
If
2 ways. One is you can go to import dataset. This is just a refresher. Huh? Import dataset. I know that my data is called in a data folder in raw data. It's called AHSCAB Rajasthan. Sorry. Okay. The moment I select it, there is a some code that will be appearing here. What I can do is I can just directly press import here. Huh? And then this dataset will be imported, but I want it to be streamlined properly. So I will rather copy the code and paste it in my R script. And I know readr is being loaded along with the tidyverse, so I just don't need this any longer. And the second good habit that we thought about is to make all our datasets,
DF.
properly named, so DF, so that we can reuse it. And here the file path is absolute. We don't want absolute file paths. We would like a relative file path. So what we can do is we can, yeah, isn't it? So this way things are fine, right?
Yes.
So right
Yes,
now
sir.
I'll just load DF, and it says DF is how many rows, how many columns.
But
Yeah. So a very quick way is that we can look at DF glimpse,
glimpse.
right? DF glimpse is giving me all this information. Most of it is actually clean, but our PSU ID, text capital, age code capital, there are some things that we can actually clean it, right? So
Yes.
how would you like to clean it? We'd like to clean it.
Only using janitor response, we can use
Janitor
that.
package. You say take DF, you say janitor, and then there is a clean names function in that, and then you would like to record it as. Now, if you look at glimpse, everything is small, right?
Yes.
PSU ID, sex, age code, everything. Okay, fine. Is that clear?
Yes.
Okay, great. Now the question comes, you all know that this is one state, one district, okay? Rural, urban is there. If you really want to see what percentage of things are, people are in the rural and urban, you can really very quickly look at that. You can say proportion of rural and urban. How to do that? We just take DF. Once we take DF, we will say count, right? Count what? Count rural underscore urban, right? Then it says that, okay, these many are rural, these many are urban, isn't it? But then we would like to have it in a table form, isn't it? So that we can very quickly write things. But I will just introduce you to a very simple package. We'll come back to that package later on, but it is called table summary. Okay, it's called TBL summary. I think it's called table summary. Just 1 second. Library. It's called table summary. Just 1 second. It's called table summary. GT summary. Sorry, it's called GT summary, right? Okay, there's this package called GT summary. And with GT summary, what you can do is you can select the single variable that you want, like for example, rural or urban. And then you can very quickly create a table summary out of it. So now you look at, see, are you able to see my window, the viewer
Yes.
window? So it's very quickly told you, okay, it is the same thing. No, earlier I wrote this one. So in the console, this is what I got, right? So how many of you can read what is happening from line 25 to 27?
Rural and urban are differently selected.
Yeah. So what actually happened is I took DS, okay, and then I selected only the column that I'm interested in, isn't it? Selects the columns, right?
Yes, sir.
And then I looked at the summary.
Yes, sir.
Okay. And I wanted the summary. So there's a function called table TBL underscore summary, which is coming from the GT summary package. Okay. And that very quickly has given you this output. Okay. It said that it's this is the different levels of rural urban, and N is totally this much. And whatever is in the bracket, it's the percentage. That's what it's trying to say, right? It's very easily organized, isn't it?
Yes, sir.
Right? So the only function that I introduced you is table summary. So this is a very quick and dirty and a very helpful function. We'll use that often when we're actually writing our reports and when you have to create publication ready tables and stuff, right? We can come up with your regression tables, odds ratios, confidence intervals, p-values, everything. Okay. We'll park this resource for now. Sorry.
So why this window come in a separate window, this output?
This output is actually coming out as a HTML. So if you want, we can ask it to prepare a Word file for you. Okay. We'll come to that. Okay. I'm just introducing you to this GT summary now because this will be the power of GT summary you will be appreciating when you learn R Markdown. Okay. So by the end of this today, what we should be able to do is we can very quickly create a report. Okay. That's what we'll try to do. Okay. We already created an R Markdown. We knit it now into HTML, isn't it? Okay. If you remember, we did this. We went to file, we went to new file, we went to this R Markdown, and a lot of options were available. You can create presentations, you can create shiny apps from templates, you can create Flex dashboard, you can create American Journal of Statistics. All these templates were there. Thesis templates were there. Plus n number of templates are there, right? You remember? Don't remember?
Yes.
Yeah, this basic thing.
Okay. So when we do that again, it will get refreshed. Okay. So yeah, anyway. So this is what I should do. I should put line 22 somewhere above, no?
Yes.
Yes.
Okay. Where do we put it? We'll put it around line 10. Okay. Okay. Now, what are the rest variables that we want to look at? Rural urban was one thing we wanted to look at. Anything else you want to have a look at? If the question comes that, okay, among rural urban, You want to find out if there is any difference in the consumption of salt in there or the amount of iodine in their salt. Okay, these are questions that I'm coming up with. Before we go there, let us look at gender. How many
Yes.
males, how many females? How many of you can tell me the syntax for that?
D.
DF, then
Pipe select.
pipe select,
Here it is.
Excellent.
Six.
sex. Okay, then
Pipe table sum.
Five.
Pipe.
pipe,
Tables. Tables.
correct?
Yes.
Okay. Fairly easy.
Yes.
Okay. Okay. Now, if you next, what else? What else can we do? Very quickly. Let us do three more variables. Okay, quickly. Come on. Any other variable? Do you want me to give you the dataset link? Will it be easy for you to?
Yes.
Anyway, I'll do that later on. But I want you to just have a look here. What other variable do you think you can have a look at? See, age, gender.
Marital status.
You want to look at marital status? Okay. Okay. How is marital status written here?
Marital underscore status.
Okay. Okay. But then the question is, a child cannot be married, no? Isn't it? So that is why you have this so many unknowns, NAs, right? Out of 6,079, many of them are maybe unknown. I mean, maybe they're not married, they're still young kids, right?
Yes.
Those who have married, then how many of them are divorced? How many of them are married and Gona has performed? I don't know what this Gona means. Anybody has an idea?
That is a consummation of the marriage. So.
Okay, consummation of the marriage, right? 309 people never married. One person remarried, separated, widow. Okay. But if you want to remove, so if you see the total, no, the percentages are already adjusted for this unknown, isn't it?
Yes.
It did not take the percentage based on this n. It took percentage based on the rest of the ones that are left. That is why this is 72 plus 24. This is 96. 96 plus 2, 98. And rest would come to the rest of 2%, isn't it? It did not take this NA. If you would have looked at, let me do the count version of this. Okay, let us compare with how count says this. See, NAs. So NA is represented as unknown here. But sometimes maybe you don't want to show NA, isn't it? Yes or no?
Yes.
You can say missing, and yeah, missing, there is an option here. Just press F1 and it will say missing, always no. I will say no. No is an option. I don't want you to show missing values. So now unknown is not there. But then the total won't match, no, to this. Anyway, so these things you have to be aware of. There'll be n number of options for you. I'm trying to introduce you to this table summary. I don't want you to feel very alienated when we work this later on. Okay. So yeah, marital status. Any other variable, please? There are lots of variables for you. Come on.
So could we do for blood pressure, sir, systolic and diastolic?
Okay, great. Systolic and diastolic blood pressure. Okay. Look at blood pressure, right? But then I would like to ask you a question. Would it matter if there's a 2-year-old or 1-day-old kid who has his blood pressure reading?
They would have never done for them.
Okay. Let us look at the blood pressure. What do you want? You want to look at the mean blood pressure, systolic?
Yes.
Okay. So can you tell me DF 5?
Select
You want to select
BP underscore systolic underscore 2 reading.
Oh, you want the second reading only. Okay.
Yes.
Why not the first reading?
That it was just opposite to my eyes, so I just told them.
Okay. Okay. Let us take BP
Yes, sir.
systolic.
Yes,
Okay.
sir.
And then what do we need to do?
Five.
What is your intuition telling?
5 table summary, sir.
Great. Let's see what will happen. Okay. What's it saying?
So the mean is 118, which ranges from 106 to 129. Is that correct, sir?
No, it's not the mean.
Okay. That
What is it?
The median is 180 and the 25th percentile is 106, 75th is 129.
Okay. So because it is mentioned here, it's the median and interquartile range.
Okay.
Right? Earlier it was N and percentage, isn't it?
okay.
You did not mention here that I want it in percentage, but it understood that this is the character or a factor variable. So you must be looking for proportions, isn't it? Whereas here it says that okay, this number looks like something that might have a distribution in terms of it's a continuous variable. So let me give you the most appropriate statistic for you. The reason this is happening is that okay, one other thing before you would like to look at the table summary is to quickly visualize it, right? Okay, what is the way that you visualize a continuous variable?
Scatter plot?
Sorry?
Scatter plot?
Scatter plot. Okay, scatter plot is for two. You need an x-axis and a y-axis, right? So scatter plot is when you have to look at relationships between two continuous variables.
Box plot, you can
Yeah.
see. For outlier.
Box plot. Okay, box plot. Yeah, okay. For outlier, I would agree box plot. But then before that, you would like to very quickly look at a histogram, isn't it?
Yes. Yes, sir.
Okay. Yeah, I would not go and say looking at the distribution of systolic BP. Okay. Yeah. There are many ways to do this. For me, I think I just need to look at the distribution of it. So what I'll do is systolic. What I'll do is I'll just say histogram. Okay. Does it look fine?
Yes.
Okay. Makes sense, no? Isn't it?
Yes, sir.
Sir.
Okay. If you'd like to do a box plot, that's also good. What I would usually like to do is just very quickly look at it. You know? So, Shruti, can you interpret this?
So they're showing the median around 100 to 150. and many outliers on the upper side.
Yeah. Okay.
The range is from,
Mm.
I think, somewhere around 30 to 180 maybe. I'm not sure, 160.
Okay. Okay. Anyway, the way we break down a box plot is that the center thicker line is the median. Okay.
Yes.
That line represents that 50% of the data lies below that line, 50% of the data lies above that line. Okay. This is the median, right? And
Yes,
you
sir.
have Q1 and Q3. Okay, the 25th percentile and the 75th percentile. The reason they are important, why you take 25th and 75th, is that they both are the boundaries for the middle 50% of the data. Okay, you can say बीच का जो 50% है, in the middle 50% of the data lies between in this gray zone. Okay, get my point?
Yes.
Okay, so that is how
Yes,
you
sir.
need to understand. And there is this one line here and one line here. They are called the whiskers. Okay, that represents 1.5 times of the IQR. It's not the standard deviation or anything. It represents 1.5 times of the difference between the Q3 and Q1 is this line here. And, I mean, this plus this and this plus minus this is these lines. Okay. Anything that falls outside this whiskers are called outliers because they are something that falls outside the normal zones, right? So treatment of outliers is also something that is important, right? How do you treat outliers? How do you account for those outliers? Is it really something that you would like to exclude from your sample and do the analysis, or would you like to include them in your sample and give weightage to them? So that's a discussion for another day. But be aware that you have to be very explicit on how outliers are treated and missing values are treated in your study, especially in your analysis stage. Okay? Am I making sense?
Yes, sir.
Okay, great. So
Sir,
this is yeah,
sir,
yeah,
in
yes.
this data, sorry, sir, can we like increase the y-axis, like it's 100, 150, like the divisions, any option like that
Oh,
to see
you want
exactly the median, to get the
you,
median from this?
you want to do this? This is what you mean? No, what do you mean, Shruti?
No, sir. Like if we have to assume like it's somewhere around 130, the median. So can we get the
Okay.
subdivisions between?
Yeah, what you can do is you can very quickly look at the summary. Okay, what summary does is it gives you this is the mean, this is the median. Okay, this is
Okay,
the
sir.
first quartile. This is the somebody's systolic is 66. This is the range, range of systolic. Don't confuse with the IQR. IQR is different. I heard that couple of you are using range and interquartile range, interchangeably, which is not correct. Okay.
Okay.
Range is minimum to maximum, okay, or maximum to minimum, okay. Whereas interquartile range is Q3 and Q1,
Yes.
okay. You getting my point?
Yes,
Yes.
sir.
Range is maximum to minimum, okay. It's totally plausible that a person can have a, systolic BP of 240.
Yes, it is recorded here.
Sorry.
I think about 200 is recorded here in this.
Yeah. Okay, this person might be a little outlier, right? This must be the 240, isn't it?
Yes, sir.
Right? Everybody else is around 200, 210. So how are you going to treat this outlier? Would you remove it from the analysis, or are you going to give him the highest other than this? Or are you going to say that, okay, anything above 200 is 200? Even if it's 201, 202, it doesn't matter. I'm going to make it 200. So these are, real decisions that you need to take, isn't it, when you're doing your analysis? But unless and until you document them, you write them and say that I'm doing this. Okay, these are the outliers I've identified, and these values I'm changing it to this. You're getting my point?
Yes, sir.
I hope
Here,
that, yeah.
yes, sir. So since here it is just one data, so is it excluding the better option, the 240, like you said?
Okay. Treatment of outliers can be something that we can take up later on. But for now, will you agree? I think that's what you suggested, that at least this 240 one should be removed, isn't it?
Yes, sir.
Do you all agree? Or you want to make that 240 into 200? Or whatever it should be. Sorry, Lokesh?
Removing it seems like a good idea. to me.
Okay, you want to remove. Parthi, what about you?
Since we have to use this code for other things also, so we could make a code of cutting down to 200, sir.
Okay. Okay, that's an okay this thing. What about you, Subarna? Subarna, are you there? Okay, Anand, what about you?
So we can mark it as the maximum reading, but
Okay. But you agree with with whatever it is, right? Later on we can deal with it. For now, what I will do is I will write some code. Anything above 1.5 IQR is called as outlier. Okay. Get my point? Anything above 1.5 IQR. So everything above this line is an outlier. Okay. Everything below this is an outlier. Okay. So what we can do, we'll say, okay, is this okay? Are you okay with doing this?
yes.
Okay. Here we found out that there was 240 is the maximum. What we can do is we can take df, we can say mutate bp underscore systolic, sorry, not bp equals to if else bp underscore systolic is greater than or double equal to 240, then it needs to be. Are we removing it for now? We are removing it, no? Isn't it? So
Yes.
we'll just filter it directly. This is enough then. If we are only filtering it, this is enough, no? See, if now can you first how many rows are there? 6079. Okay. Now when I filter it, it is actually 60. Oh. Okay, there are NAs also, right? How many NAs are there? 3,000, so many NAs. How many observations here? 60? 79,
7,
and we have removed one. Okay,
6078.
6078. Okay. For now, I'll just do this part. Okay, this may not be the most ideal thing. And now, if I, sorry, just take this. Okay. Earlier, it was this. You see the difference?
Yes.
Okay. That's fine. Okay. But then now the question is, we have two readings for systolic, two readings for diastolic. Let us do the same thing for diastolic. Will that be okay?
Yes, sir.
Okay. Let me look at diastolic here itself. Okay, 77 diastolic. Okay, let me look at the histogram for diastolic. Okay. Okay. There are some outliers in the this thing, largest, I mean, right side, no? But
16.
yeah, it looks like it's an okay distributed thing. It's not biologically not plausible. Sorry, isn't it? It's possible that these readings are there, no, in real life scenarios, isn't it? Do you agree?
Yes.
These readings are plausible in real life, yes or no?
Yes.
Okay. But then you would like to remove this, is it?
I
216.
think yes, sir. 140 above only one time.
Yeah, you want to remove this 216, is it? Oh, not systolic, diastolic, no? Yeah, 151 is there. So you want to remove this 151? Is that okay?
Okay.
I know this is not the best way that I'm doing. Yeah. And definitely you should not follow this method. But we will, for now, I hope you all agree. Don't you?
Yes.
Okay. What I did was I selected two columns and then I did a table summary. So yeah, this is the systolic, this is the diastolic. Okay. But then I also have second reading of systolic and second reading of diastolic. Don't you think it is better if I get a, okay, let me look at those also. Will it be okay if I look at those?
Yes.
Okay, I'm being lazy, but okay. BP systolic second reading. Okay. But then there are some readings where, I mean, okay, 1 second. here also 220 was the maximum, right? But not 240. Okay. So here this value is not being removed in the second reading. Let us look at here. Okay, here it says 135 is the maximum. So that is also not being removed here. Okay. So now the challenge for you is to come up with a composite value for hypertension. Okay. So now you have systolic BP once,
That's
systolic BP second reading. You have diastolic reading 1, diastolic reading second reading. Okay. Now, if I ask you, I want you to classify if this person is hypertensive or not. Can you tell me how to do that?
We need the mean of,
If
we can put
then
mean of first and second reading for individual people.
How to do that?
you can use mutate to create a new
Mutate to
variable.
create.
Isn't it?
Yes, sir.
Okay. So how to do that? Can you guys tell me how to do that? We'll take DF and then you suggested mutate. Okay, I'll say mutate. Then
why we are creating mean systolic and mean diastolic?
so you want to say?
Why we choose mean systolic and mean diastolic instead of systolic and diastolic?
Correct. So we have two readings, right? So one reading might be 150, the other reading might be 160. So then we can say the mean of both of them is 155. So that's how usually it is done. Two readings are taken in large head because sometimes people take some time for their BP to settle and things like that. Okay. So two readings they have taken. So we can call it BP systolic mean, okay, is equal to, come on,
BP underscore systolic within parentheses. Oh, okay.
BP systolic 2 reading.
isn't it?
Yes.
Okay.
Okay. Now I can just do the same for diastolic. Okay, it's saying that something is wrong.
Underscore and diastolic too.
Okay, 1 second. BP DF dollar BP diastolic reading, isn't it? This is correct. Diastolic is correct. So why is it not working?
With the underscore and BP diastolic, sir. Before that RN.
No, this is correct only.
No, sir. Two. Okay.
Error is caused by, what is written in error is caused by error in mean before.
Okay. Okay. But then this should work. Let us look at it's asking for an argument trim. Let's see if it will work. Now it is work. Okay. Yeah. Okay. Now it has created this thing. Now let me write it back into BF. Okay. So now that I've written back, what I'll do is I'll just take the systolic in and get the diastolic. Okay. It says that this is the value, and it's giving it in NN percentage, which we don't want. No? We want it in standard deviation, right?
Now how the N is 6076, sir?
Sorry,
N is 6076 now.
because we have removed. We have said that one of the. Okay, what's happening is that if any of the NAs is 0, it's taking T. But what we can do. Another way, I'm just playing around. I'm just playing around. Yeah. Say the first one worked, the second one didn't work. There are a number of reasons for that, but yeah, it's fine. Okay. Now let me look at the data. Sorry?
Sorry, sir, but why did it give in N percentage in this? Because if it's a continuous variable, it
Yeah.
normally gives the median.
Just bear with me. I'll come to that.
Okay.
So here, okay. What's happened here is that many of the values, right? See, this one, what was the mean here? 111, 111, 111 is there many times, right? BP systolic. You want all continuous variables to be given as mean standard deviation, right?
Yeah.
What I will do is I will just select this, just paste it here. One second. Type equals to okay. But then there is an issue here. Okay. Okay. Earlier, what happened was that when I asked it to create the systolic mean, and it took 2 columns and calculated the mean, I'll just remove this row wise from here. Okay. I just created this. Now, if I go to my DF column and look at the column called, what did we create? Systolic BP underscore systolic underscore mean, right? Isn't it?
Yes.
You would see that all of the values, okay, right now would be either NaN, just once. Okay. See, all the values in systolic mean has changed to the actual mean value. Okay. Which is not correct, isn't it? We wanted the mean value. Okay, let me just add these also so you understand. You have to be a little careful when you're doing these operations because you might think that everything went on correctly or right, but then you see that you actually did something wrong somewhere. Okay. The first reading, when BP systolic was not there, no entry. Second reading was no entry. The third, the mean should be NA, isn't it?
Yes, sir.
But somehow it gave us the mean of the whole of the data set, which is not correct. You agree?
Yes.
Okay. The second one, again, the mean should be 136, isn't it?
Yes, sir.
But what
Yes.
happened? It gave the whole of the data set. Okay. Now, I hope that I don't have to go through everything. Here it should be 136. Here it should be 118. Am I right? Here it should be 126, isn't it?
Yes.
So now, what I'll do is I will just uncomment this one. Okay. I'm going to say that do this calculation, this mean calculation row wise. For every row, do it separately. I don't want you to do it all at once. Okay. Now, when I say do it row wise, now look at the data. Okay. Maybe it's because of the trim. Okay. It's only taking the first one, right? BP underscore systolic underscore Q underscore reading. Then I don't need trim. Still. That should have been the same, no? Just 1 second. That means that we estimating row means. Now let us see whether it will work or not.
First,
It's interesting because it should have happened. This should have been the mean of this, no?
It is wrong, the first observation.
The first observation, yes.
Sorry. Yeah, it's still giving us the first observation. So, okay, what if I do it this way? Now I know it will work, but then I'm not pretty sure why the earlier one didn't know about. Interesting. If I take the mean of this and see, I think, is it because of the trim? Trim is by default 0. Anyway, let's put it as 0. This is the default. Now this is the issue. Okay, this is interesting. But then if I say this by this plus this by 2, if I did, what do you think this will this work?
It is what we do on Excel. I thought it was.
Sorry?
This is how we do it when we are using Excel, right?
Yeah. No, but I'm just having a look and figure out why. But then this is interesting. I used to never face this problem before. So I'm fascinated. There must be an explanation. No. But is this giving us the correct value? There's an extra comma. Can anybody figure out extra comma where it is?
First, mm,
They're just showing the comma at the end of first. And I mean, BP systolic mean.
So then I should yeah, this is working. Okay. This is working, no?
yes.
Yes.
Yes. Sir.
This is working. Okay. So that yeah, I think then row means should be something that we should be careful about. Okay, just let me very quickly. They are proposed this way. Let us try this. This is fine. Let us. This one is working, right? The first one.
Yeah.
So what we'll do is take row means as this. Yeah. Let us try this. This also worked. Okay. Somehow, when you are mutating row means, you will have to pass it as a separate data frame. That is what I'm understanding here. I know it didn't make sense, but be a little careful when you're calculating row means. Okay, row means or column means or whatever when you're doing things in R. Just cross check whether things are actually happening correctly or not. I think that is the take home message. What is the take home message? That don't blindly believe that whatever is happening is correct. Just have a look for yourself. Cross check if things are correctly done or not. Otherwise, if you would have taken things for granted and not looked at it, we would have realized that we are doing things wrong, isn't it?
Yes.
Okay. So now I know that this is working. I'll leave this as this also here. Okay. And now let me, yeah. Yeah. So mean is 120. Median is, mean is 120. Standard deviation is 19. For the systolic, for diastolic 78, standard deviation is 13, right? So I don't think so there's a very huge hypertension problem, but what we can do is we can classify this, person into a hypertensive or a non-hypertensive, or hypertensive or normotensive, or we can classify them into isolated systolic, isolated diastolic, and frank hypertension. You're understanding what I'm trying to say?
Yes,
Yes,
sir.
Okay, let me type it down here so that it will be clear. Classify individuals into just to make things simple. I mean, if you want to make it simple, it can be HTN present or absent. Okay, or so this would be based on what is the classification you remember? Systolic BP being
122, 129.
140, no?
40 by 90.
Sorry, what is the classification of the hypertension?
140 by 90.
140 by 90. Systolic
90.
needs to be greater than equal to 140. And
Diastolic.
yeah, diastolic needs to be greater than equal to 90, isn't it?
Yes.
Yes.
Then you would call them hypertensives. Or it could be possible that somebody is 150 by 80. Is he hypertensive?
Yes.
Huh?
Yes, sir. Isolated systolic.
Okay. So it's called isolated systolic, no? Isn't it?
Yes.
Agree?
Yes, sir.
A person can also be having 120 by 100, isn't it?
Isolated diastolic.
Isn't it?
Yes.
Okay. So yeah, we'll call them isolated systolic, isolated diastolic, and frank hypertension and normotensive. Is that fine?
Yes.
Okay. Great. So we'll say
For this isolated systolic, we again have two things. Right. That means if the systolic is greater than or equal to 140 and diastolic greater than diastolic less than or equal to 90. Something
okay.
like that.
If isolated systolic will have systolic greater than, sorry, if isolated diastolic will have systolic greater than 140, they will become frank hypertension.
Oh.
Okay. Frank hypertension is where systolic is greater than equal to 140 and diastolic is greater than equal to 9. Okay. So yeah, which is the most ideal function to do this?
Case when
Yeah. Okay, great. Mutate, and then we can say case when. Okay, we'll call it hypertension category equals to case when BP systolic underscore mean is greater than equal to 120.
140.
Sorry, 140. Then you call it
Isolated systolic.
okay.
Yes.
Okay.
Sir, is it not required to say the condition of like the diastolic, no, systolic less than also? Only one line is enough for isolated systolic and diastolic.
Mm,
I mean,
Shall-
sir, like,
shall we
so
check?
I meant,
Shall we check if it's working or not?
yes.
Um, Let us check, huh? I know it's it. I am also not sure if it will be fine. Let us check that. Okay, the first one,
NA.
NA. It should not be normal tense. It should have been NA, no?
NA.
Isn't it?
Yes.
Yes.
Okay. Okay.
Yes. Oh, so
Happy?
Yeah.
This one is isolated diastolic because greater than
90.
all these are less than 120, 140.
Yes.
Yes,
Whereas
sir.
the diastolics are greater than 90.
90.
Yes, sir.
So isolated diastolics. Okay. These are all isolated diastolics. Now isolated systolics have come. 140, 162 by 100. This should not be isolated systolic, no?
Yes, sir. It should be frank.
This should have been frank, isn't it?
Yes, sir.
So for frank and or which is correct?
It has to be both, no?
Okay.
Let us see. Yeah, see now frank hypertension, no? These are all isolated diastolic, right?
Yes.
Now isolate systolic. Normal tendency. Isolate systolic. Isn't it? So this one is isolated diastolic, right?
Yes.
Yeah. I think now the classification is correct. Okay. It's also important when you do case well because it will also depend on what you do first and then what. So first, basically, it's going to look at this condition, and then it is going to name this frank hypertension. And whatever is left, then it will go to this. Okay. Earlier, what we were doing, we were saying that do this and then do this. So it is misclassifying things because earlier, if diastolic is greater than 90, it is making it as isolated diastolic. It's not looking at the first one as well. So it's also important on sequence of what you need to classify. Is that making sense?
Yes, sir.
Yes.
Yes.
I know today's session is a little boring, but these are the things that are troubleshooting, right? This is how you do it. There's no other way you can learn this. You have to sit with this way. No?
Yes, sir.
Yeah. Okay. So yeah. Now that we have done this, I'll do one thing. I'll just save it as DF. You know? And now what I can do is I can take this DF and then I can select hypertension category. And then I can say table summary, isn't it? And then this is what would come in the sense that it would do a count of it and give us the proportions, isn't it? Does it make sense?
Yes.
Okay. Now, the question is, okay, now this is fine, but then I want to see, is there any kind of difference between males and females?
Can
Do you
we
think
add that in? In table
Sorry?
summary. No, sir. Is it possible to add that here?
Okay, good. Okay. So what we can do is you can select sex as well, because that is what you need to select if you want to add by group. And then it's a by equals to sex. Yeah. Sex does not exist. Why does sex does not exist? DS. Okay. Are you seeing?
Yes.
What does this table tell you?
How many female have a frank hypertension or isolated diastolic hypertension? And how many males have that?
Okay. So would you like to, is there any difference?
Frank hypertension and isolated diastolic are higher in males than females.
Okay, good. But then my question is this difference statistically significant or is it just by chance?
We need to know the p value. Say that.
How do you do that?
Find p value.
Anna, you take
Yeah.
a pipe, you say add underscore P.
Okay.
Yeah.
Okay.
Is it nice?
Okay.
Okay. So now what it is doing is it not specify that you need to do PSM chi-square, right? Because it knows it's a test of proportions, right? Your age is also, sorry, gender is also a proportion. Your category is also a proportion, right? So test of proportions for two samples is a chi-square test, and it's already applied your chi-square test. And it says, yes, whatever difference you're seeing is not just due to chance. There is a genuine difference between both the genders when it comes to hypertension. And I think it's plausible, right? Because males are at higher risk of NCDs as compared to women because of any number of things, because of their habits of using tobacco, alcohol, age, a lot of other things. Though, see, we are not accounting for covariates here. How many of you understand the concept of covariates?
I understand.
Is it different from confounding factor?
Okay.
Yes.
Okay. For example, let me give you a situation, right? So now,
Sir, one doubt. The p value it calculated is for all the categories. So individually, because there is normotensive also. So based on that, it has calculated the p value also and unknown also.
yeah.
So is
See,
it
yeah, when you, it's not unknown, unknown has been removed. Okay. Basically, what it is doing is a basic chi-square test. And when you look at the literature and theory of how chi-square test works, is that it, based on the sample,
Yes.
It'll assume that, okay, if you have 100 people and you want to find out, okay, is there any, association of gender?
Yes.
So you would expect that if 100 people are there, 50 would be male and 50 would be female. If there is no association, okay, if everything goes to random or everything is normally distributed, you would have equal representation, isn't it? So that is called your expected value. But when you do the when you do the categorization, you find out that your observed value is different from your expected value, right? So if you remember correctly, when you read chi-square test, there is this observed and expected, and sum of observed divided by sum of expected, something like that, isn't it? Observed minus expected and all of that, isn't it?
Yes, sir.
Are you aware of that?
Yes, sir.
Okay. So I would suggest that you go through, what a chi-square test is, and there are other tests also. I think that refresher, you need to do it on your own. But if you are preferring that that will be helpful for you, then I can take it up also. Do you think you can manage on your own all the different statistical tests, or you want a primer for that as well?
We can read.
Sorry?
We can, I think, read on our own because that
Okay.
would be then. I
Okay.
don't know about others. Parthi and all are first years here. So
No, you can just speak out if you want that. If not, we can think about something else. Okay. Okay, if you need that, you just let me know. I can very quickly give you an overview on at least linear and logistic regression. But anyway, the point being that anything further, if I go, that would be under the assumption that you know little bit of statistics. Okay.
Oh, yes.
I would assume
Yes.
that you know linear regression. I would assume that you know how to interpret, the beta coefficients. You know what is an R square. You know what is odds ratio. You know how an effect modifier works. What is the difference between an effect modifier and a confounder? So these are the assumptions that I'll be thinking about. So if you want me to wait for you to, maybe till next week, we can give you time in the sense that you can have a refresher on your own. I can share some resources, but better you have your own, comfort zone. Because
Okay.
anything further here would be oversimplifying some basic concepts, and those concepts are critical. For example, how many of you have done a logistic regression?
I didn't do the anything independently, sir, but I saw the
Okay.
articles, journal articles of that, but I didn't do anything independently.
Okay. What about you, Lokesh?
no, sir.
Haven't done it before.
Shruti? No.
No, sir.
Frederick, sir?
Yeah, I have done, sir.
You
Published
have
some
done that.
papers.
Yeah, great. Okay, then. What we can do is, I think that bare minimum, if you are able to get there, then things will get very interesting, right? It's like before you can enjoy sports car, you have to have license, driving license. So, and basically you should understand that this is steering and this and all. Now you're all comfortable, right? You all know everything. You're able to help me out, troubleshoot things and all. You can read the code, you can understand, you can help me out in structuring the code and all of that. But what would be helpful is for you to have some parallel readings, like maybe some statistical understandings you should have, assumptions. I'll share some this thing with you. At least linear and logistic regression, multivariate linear regression, multiple logistic regression, this much is a bare minimum. Okay, especially for a public health professional. At least logistic regression, till there you have to go. Forget
Yes.
about any kind of weighted models and all of that. That's a different story. But once even if you are thinking about doing some kind of a spatial analysis, all that is again based on regression. Okay. So till regression, you should be clear. And if you are having any doubts, you can just discuss with us. I think even Frederick sir would be able to help you out in clearing the concepts and things. Okay. Shruti, I was hoping that you would have done something already.
No, sir. Actually, I haven't done logistic regression now. It's the only simple, like very few
Okay.
research work happened.
Okay. Now that this is done, and this is okay, now I can do one thing. I can also test my question whether it's only sex or is it rural urban also. That is. See, it says that okay, rural people have lesser hypertension as compared to urban people, isn't it?
Rural people have higher.
Sorry. Almost double, right?
Yes.
Yes.
Yeah. Okay. Now, I was trying to bring in the concept of covariates, but I don't know if it's a good idea. Maybe next time, once you have just a brief overview on regression, maybe then I can bring in the concept of covariates. Okay. Basically, the idea is that is there an association between smoking and lung cancer?
Yes.
Okay. But do you think all smokers will get lung cancer?
No.
They are at increased risk of developing.
Good. What are the other factors that can influence your chance of getting cancer?
Genetics.
Genetics.
Then
Age.
age. Good.
Occupation, sir, occupation also.
Occupation. Good.
Environmental pollution.
Environmental pollution. Good. Yeah. Okay. So basically, the thing is that there are some modifiable risk factors, non-modifiable risk factors, isn't it? So all of them do influence your chances of getting cancer, right? So they also vary along with, say, when I'm saying smoking and lung cancer, yes, but nobody said if I'm smoking only 1 cigarette a day and another person is smoking 10 packs a day, is our risk the same? Right?
No.
So here the covariate is the amount of smoking that we're doing, right? So that is the variant. That varies very concurrently. So it varies together with the exposure and the outcome, right? So that's why it's a covariate. You get my point.
Yes.
Similarly, age, gender. Usually, age is a very good classical example of an effect modifier. Okay, effect modifier is, for example, just like Anand has mentioned, that the chances of cancer won't be the same across all ages, right? When you're young, the chances of how much ever smoking you do, the chances of getting lung cancer is less. Whereas your age goes up, even if you take small amounts of alcohol and tobacco, it might increase the chances of your ailment much higher. So age is an effect modifier. The effect of the disease or the effect of the exposure on the outcome will vary with age, isn't it?
Yes.
So you have to understand these concepts. What's a confounder? What's an effect modifier? How to remove confounding? See, confounding is something that we need to remove, right? We don't want I'll just give you a classical example. I'm sure everybody knows of this, but that one very important study once was published in one of the reputed journals saying that pancreatic cancer is caused by higher levels of coffee consumption. So it was found that yes, whatever the analysis they did, they found out that people who are actually drinking coffee more tended to have higher chances of or higher rates of pancreatic cancer. But then when they broke it down and they did some kind of segregated analysis, cross tabulations and things, they found out that it's not actually coffee. People who drink coffee are usually people who are, who wants to stay up, who are in the executive business, who are, businessmen or working class, who tend to also smoke a lot. So they found out that it's smoking that is actually causing the lung cancer, and this coffee drinking was actually the confounder because it was related with both the outcome and the way, exposure. So confounder should be removed, right? You have to say that, okay, this is a confounder and its effect should be removed before you say that the true effect of smoking or the true impact of cancer is due to this so and so. But whereas effect modifier needs to be identified and it has to be brought out. Okay, so this is the effect modification of this. So basically, what it tells you that okay, the highest variance or highest effect is caused by this variable. So if you control this variable, its effect will drastically decrease. Things like that. So these are concepts that are central to epidemiology and public health, and I would not expect this to be very common sense to people like Anand or young this thing to Lokesh and Parthi, but it will definitely help you guys to have this understanding. Okay, because these concepts are always going to repeat every even 20-30 years from now. These are the concepts that are going to stay. Okay, so if you get these foundations clear, everything else will be very smooth. Okay, anyway, so it's not just these variables. Now my question is, here I've classified hypertension category, isn't it?
Okay.
But what if I take raw hypertension values, okay, and then look at, is there any difference by gender? You getting my point? Right now, it is hypertension present absent, or frank hypertension present absent, or things like that. But I don't want to categorize hypertension as present absent. I want to say that systolic BP value is 16 or 116 or 182, right? I want to find out what is the mean difference between both the genders when it comes to systolic BP and diastolic BP. How to do that? So I will take my data frame and I'll select the variables that I want. The two variables that I'll be selecting is BP underscore systolic mean, and let me do it by gender, sex. Okay, so these are the two variables that I'm selecting. Okay, and now I want to find out that the mean systolic, is it different across genders? So I can just take table underscore summary for this. So right now it's going to tell me that this is the mean overall, but I want to divide the mean by gender. Okay. So y equals to. So now it tells me that the mean systolic pressure of a woman is 115 with an interquartile range. Sorry, this is the median. The median systolic of a female is 115 with an interquartile range of 104 to 126. Whenever I tell you this numbers, you should in your mind draw a box plot imagine that there is a thick line here, which is around 115, and there is a gray shaded box. That means the middle 50% of the data are lying between just 104 and 126. For males, it's a little high, isn't it?
Yes.
You agree? Yeah.
Yes,
Yes.
sir.
But now the question is this difference statistically significant or not? We tend to do with p-values, and that's not a very good practice. That relying on p-values is not a very good practice, but it is the conventional things that majority of your teachers or the people reviewing your articles, they will look for. So what we can do is we can use the same function that we have used before, and then we can ask it to add p-value. And then it says, yes, there is a statistically significant difference between these numbers. And it has given us the Wilcoxon rank sum test, because that is the non-parametric version of a t-test, isn't it? How many of you have heard about
Sir.
t-test? T-test?
Yes, sir.
Yes.
Yes, sir.
Okay. Chi-square test?
Yes.
Yes, sir.
These are all
Sir.
parametric tests, right?
Yes, sir.
Yes, sir.
Yes,
There
sir.
is a version of them called a non-parametric test. I think it will greatly help us all if you just have a brush through about all this. Okay, I'll share some resources whenever you have time. You just go through them.
Yes.
But if you
Okay,
remember, last time we did not want it to show median IQR. We wanted it to show what
The
do you want? Yeah.
mean.
So what we'll do is we'll just go here. We'll within this itself we'll select. Yeah, we're not using diastolic here. Oh. Okay. Even now it is done. In add P, I can select here. Test. So T test. No? I can say say. Okay. You have earlier it was Wilcox's sign rank. That would suggest that this is a non-parametric distribution, but still we looked at the distribution, it looked a little normal to me, isn't it? You remember? So anyway, okay. No. When we looked at the distribution of this variables, the histograms, they look like they follow a normal distribution. Okay. Normal distribution is a special kind of distribution, and it's called a Gaussian distribution, where it's something like this. Okay? It's symmetrical in nature. Okay. One standard deviation. So this is the median, sorry, mean. Okay. In a normal distribution, the mean, median, mode are always the same, okay, or around the same. And 1%, one standard deviation follows, encompasses around 68% of the data. Two standard deviations, mean plus minus 2 standard deviations will encompass 95% of the data. Mean plus minus 3 standard deviations will encompass 99.8% of the data. Okay. So when you look at this distribution, it looks symmetrical, though the mean, because of these outliers, the mean would be pushing towards somewhere around this side, not the middle. But still, it looks like a normal distribution. Okay. So I would prefer, though it might seem like it's the computer is asking you to go for a non-parametric test. I would still go for a parametric test. Okay. Just because my experience says that, or that's a call that I have taken. Okay. It's not very different. If you look at the mean and the median, the mean and the median is not really different by much. If you look at the summary.
Sir,
Yeah, mean and the median are not very different. Yeah, sorry.
to check the normality of the data, there are some tests like Kolmogorov Smirnov test. Can we use that here?
Shapiro test is there.
Separately, Kolmogorov Smirnov.
I think it's Shapiro test is there. There are other tests of normality also.
Kolmogorov Smirnov.
Yeah, I'm not getting the function for that. Yeah. Yeah, it's for the non-parametric data. Kolmogorov is like the non-parametric version of Shapiro, but I'm just looking for the, I think it's called KS test, is it? Yeah, KS test. This is what you're suggesting?
Yes, sir.
Yeah, you can do that. You can check it. So you can take this. So p-value is less than 0.05, right? Yeah. For the Kolmogorov test, it's a non-parametric version. So you need to have y that is drawn for the sample. Anyway, so you can. But Shapiro test is suggesting that the p-value is less than 0.05, right? So if you look at the way you interpret Shapiro test, so it gives out a p-value, and what it says that is, now, if a p-value is significant, then that means that this data is normally distributed. If it is not, then it is not normally distributed. Okay. Don't confuse. I hope by now you know how to read this. This means that minus 16 zeros are there before this 2.2. Sorry, 16 zeros are there. That means it's very highly significant.
Yeah.
That's his normal distribution. Yeah,
Yes,
don't a very quick one is to just look at the histogram. Histogram very clearly tells you whether it is normal or not. So anyway, so now that this is done, okay. Now what I want you to have a look is, let me go to this data set once again. I'll open this data set. This time I'm going to which was the district that we used before? Rajasthan, right?
Rajasthan, sir.
Okay. This is not what we want. Yeah, Sihori, Rajasthan, right? Now let me look for Bhagalpur, Bihar. Now I just want to show to you that all the code that we have used is actually, we can repurpose. We can say L7X9ER. So we have downloaded a CSV. Let me copy that CSV and I'll paste it in our data folder and raw data. AHS cab Bihar. Okay. So now what I can do is I can very quickly okay. I can run the whole thing. You're seeing every table being generated.
Yes.
Yeah.
Okay. So what this is saying is that let's just think about our hypothesis generation and just reflect on the concepts of reproducible research that we did.
Yes.
If we do the same analysis on a different data set and we get the same kind of results, then we would say that there is some kind of replicability or reproducibility in the research, right? Earlier, if you would have seen in Rajasthan, we found that women had lesser hypertension as compared to men. And this in Bihar, we are seeing the opposite. Isn't it?
Yes, sir.
Okay. So that would mean a couple of things. Okay. One, maybe it is not just gender that is responsible for this, difference in hypertension, isn't it? It could be age. It could be age. It could be place of residence. It could be many things. Correct?
Yes.
I hope you're not lost. I just need some feedback whether this is making sense. Because earlier we found out that in Rajasthan, in the district of Sihori, we found out that women are actually having lesser hypertension as compared to men. I mean, just the prevalence. Whereas in Bihar, which district was this? Sorry. Bhagalpur district, isn't it? We found out that the story is opposite. Now let us look at Odisha. Okay. What is Odisha saying? Both district in Odisha. Is the story the same here? The same thing. I will just copy this
to raw data.
and then I'll put it in raw data. This is the file name. I'll just very quickly rename the file name. Just pay attention. I'm just selecting everything that we have did till now and I'm just running it. Look at the viewer window. Here it says that, yeah, women are lesser. Sorry, not in rural areas, right? Yeah, women are lesser. Okay, or all see p-value is, what is the p-value?
0.7, not significant.
Okay, so they suggest that in this data set, it's suggesting that no, there is no real difference in men and women when it comes to just hypertension, frank hypertension. Okay, so now three things are telling you three different things. Now, how do you take that? Because three things are saying three different things, right? Now, how would you take that? An ideal thing would be to pool all of them, isn't it?
Yes.
Agree?
Agree.
Okay.
Yes, sir.
So now we have three data sets. Okay, let me what I'll do is I'll go to the raw data folder, okay, and then I'll ask it to list out all the files that are there. So Bhagalpur, Baud, Sihori. So these three are the CSV files. Okay. So I can basically what I can do is I can ask it to say yeah, glob equals to. Yeah. Okay, I'm asking it to give me all the CSV files. So there are three CSV files. Okay.
Yes.
Are you guys getting this line 16 and 17?
No, sir. What is glob? You have written something.
Okay, I've looked at the documentation of it. I only want in this folder, in this raw data folder, there are n number of files. Okay, 1, 2, there are 6, 7 files. Yeah, there are 6, 7 files. I'm only interested in the CSV files. Okay, so I asked to go to this folder and look at the CSV files and give me the file names. So it said there are three files. These are this. Now what I can do is I can map df and read underscore. So, and then I can call it DF. So now look at what DF is. How many rows is DF?
19679.
19,670.
Okay. So what actually happened in, basically these are three different lines of code where three different data sets are there, isn't it? Ideally, you would have done
Yes, sir.
DF1 or DF Rajasthan, DF Bihar, DF Odisha, three different data sets. Then you would have
Yes, sir.
combined it and then done the analysis, right? So what I did here in line 17 is that I went to this folder and I picked all the CSV files. And then I said, read all of the CSV. I said map. So if I do this, this is going to give me the list of all the CSV files. Okay. So what map is doing is for each of the CSV file, do whatever is there within this bracket. So it is reading that CSV. And then I'm asking it to write it as a DF. This is iterative programming. So the moment I run that, I can just do everything. So now I will get the pooled analysis. Now when I've taken all three data, now I want to find out whether there is a difference between male and female in systolic BP. Yes, there is a difference here. Between urban and rural also there is a difference. Rural seems to have lesser hypertension. And women tend to have more hypertension. This also I'm not still agreeing. Okay. The reason might be that the sample size that we are getting from each of these places might be different, right? Like for example, the sample size coming from Odisha
Yes, sir.
might be less, from Rajasthan might be more. So that might be causing this problem. So ideally what we should have done is to get all the data that is there here. Okay, how many data sets are there? Around 283 data sets are there. You should download all of them, put them in your computer, and then you run this. Let me add a couple of more districts just for the sake of this. Bastar, we can add Bastar. We can add Bareilly. We can add Begusarai. Let us add these three very quickly. HLHTM4 download. We can very quickly write an algorithm to fetch the URLs of all these 183 links, and you can mass download them as well. Okay, that's also possible.
So within R itself.
Yeah, this is all within R. You don't even have to type your username, password. That also you can ask it to type for you. Okay. You want to learn that?
Sir, how will it handle the captcha?
Yes, sir.
Yeah. Captcha, you'll have to, that's the thing about captcha. Captcha is there so that humans are there. But only captcha is the one that you need to enter. Okay. But yeah, there are other ways you can do that as well. Huh? I think Bastar is done. Bareilly. Bareilly. A4G9H. It's possible to do it with capture as well, but that would require some kind of understanding about how image processing works. So I'm just going to paste these 3 districts here. See? Okay. Now I'll just rerun this. I'll just open my RStudio and go back. I'll just run this. Now, what is DF? How many rows is DF?
19676.
Now I'm running this. Now, how much is DF?
40,000.
Okay. And you can just very well select everything and hit enter, and all your analysis is done again. Okay. Now, within the span of, now you have exponentially, it took you now how much time for you to do the same analysis for other districts?
Very less.
Half a minute.
I think very less is the understatement, no? Isn't it?
Yes, sir.
So this is the beauty. I mean, and this is what I'm trying to tell you, that it will, you can very easily cut short the time that you do if things are done properly. If you invest some time in doing the correct steps, step 0 was very important, right? We all must be thinking, what was the point in actually creating a project, right? What was the point in insisting that here should be used and all of that? Why DF has to be there and things? You get that point? You could have easily said DF1, DF2, or Orissa data. But if you would have done it that way, this time that you have saved, this thousands of seconds, whatever, you're getting why I was insisting that DF, use DF, use DF.
Yes, sir, yes, sir. Like now I can see why I should not have been TV data for me.
Okay. Get my point? Now you find out that majority of the people or data is actually coming from the rural areas. Earlier it was 50-50 almost, right? Now you see that, okay, quite a bit of data is coming from rural areas. And rural areas, you might tend to have people who are non-treated, right? So when you go and measure their BP, they might have high BP. Whereas in urban areas, they tend to have, they will have access to medicines and all of that. So their BP status would be fine. It will also, see, one major or very important factor when they did this survey back in 2014, they did this study when I initially started my MD days. I was in my mid MD, whatever, second year, third year. So I called the people in charge to conduct this study, and I asked, all this is fine, all the data is fine, it's very good. But how would I know if a person has normal BP after taking medication or before taking medication? You getting my point?
Yes.
We are saying BP is high, or BP is low, or BP is normal. But we don't know if that person has taken medicine or he's taking medication. That data is not captured. So this basing any kind of inferences or drawing any kind of inferences on hypertension using this data is worthless. Because you need to actually think whether a person is actually taking medicines or not. Before you say, okay, normal, his BP is normal, that means it's okay. But he might already be taking Telma 80 or 100 or whatever, right? He might be taking some medication. That variable
Sir,
needs
if
to be...
anyone is taking antihypertensive medication, irrespective of his BP readings, he is hypertensive.
I know, but how do you know if he was taking medication or not?
Yes, sir. This data is missing in the data set.
So that is the point, that we are trying to estimate hypertension or burden of hypertension, but key values or key variables we are missing. Okay? So don't, again, the moral of the story is that don't get too fascinated by the data, what it is saying. also be a little critical about where the data is coming from, how it is being captured. Is it being representative of all areas? You get my point. How is the sampling done? What is the sample size? So all that matters. Okay. And there will be very many issues, because don't blindly trust R also. R is only a tool for you. It only enables you to ask questions efficiently and answer these questions effectively. I mean, the turnover time is very less, right? Right now, we looked at Odisha. We wanted to see, okay, how is it happening in Chhattisgarh? It just hardly took us 5 seconds, isn't it? So that latency will be reduced, but still the quality of questions will only come when your understanding of the subject and things are a little elevated. Okay, you will reap the best. Anyway, do we have time, or can we stop? Sorry,
I am free.
okay, you're free. What about the rest?
Sir, I
No
am.
problem.
No problem. Okay, so what I will do is I will introduce you to an R Markdown file. Okay. Or do you want to work a little more with this data?
Wanted to see R1.
You wanted to see R. So I'll create a new file. R has n number of options for you. Okay. It's like Netflix. No, you open Netflix, 10 minutes, you're staring on the screen, what to watch. There are too many options, right? It's the same problem, right? Too many options, but you can stick with R Markdown, though a newer version of R Markdown has come called Quarto, Quarto. But R Markdown is still going to stay at least for the coming 50 years. Okay. So yeah, we'll start with an R Markdown. There's nothing wrong with it. So the moment you press a new R Markdown file, it's going to pop a window for you, and it's going to ask, what do you want? You want a document, you want a presentation, you want a shiny app, interactive app, or you want something from a template. For now, I will leave it as a document, and even in a document, it will give you options to write the title, who is the author, what is the date, what output format do you want? Do you want it as an HTML? Do you want it as a PDF? Or do you want it as a Word as well? For now, I will leave it as the default, which is HTML, and I'll press OK. The moment I press OK, a new file has opened here. Yeah, let me minimize this. A new file is opened. This file has this round color extension called RMD. It's written here. Just like here, R is written on the untitled one. Here, red color image is there. That is called untitled 2. It's written RMD. I don't know if you'll be able to see. But once you look at the RMD file, there are some unique things that you're able to see, right? Which is not there in the script. When you open a script file, when you open an R script, it gives you a blank thing. Okay. Whereas you open an RMD file, it is giving you some text. Okay? Let us try to read that text. First line says 3 hyphens, 3 dashes, and then it says title. Title is untitled. Author is Arun Mitra. Date is today's date. Output is an HTML document, right? These we did not set it here. When we went to the drop down menu and said, so these are the ones that are actually setting. You get my point? If I would have said title is my first RMD document, it would have written my first RMD document. If I would have said author is some other this thing entity, that person's agency's name would be here. You can set everything. If you select PDF document, it would have been a PDF document. I leave it for you to have a look at your own leisure. But just pay attention here for maybe 5 to 10 minutes because this is quite important. Okay. So whatever you are seeing in between lines 1 to 6, okay, it's encompassed in hyphens, 3 dashes, right? 3 dashes. This part. Okay. This has a special name. The name for this part is called YAML. Okay, it's called YAML. YAML. Okay. There's a package called YAML also, but it's called YAML. Just remember that. Okay? It's called YAML. That is where the metadata of an RMD file is. When I say metadata, metadata is when is the document created, who is the author, what is the output format. You can have multiple formats. The same document you can create as a PDF, as a web page, as a website, as a Word file, n number of ways you can create the same document. And this is where all the output formats are specified. Okay. The second part, what you're seeing is this. Something that is encompassed within 3 backticks. You remember that backtick I was talking about just below the escape button? The backtick. 3 backticks. See, whatever started here with 3 hyphens is ending here with 3 hyphens, right? So this part is called YAML. Anything that is within these 2 3 hyphen lines is called the YAML. It contains the metadata. All the codes that needs to be executed by R are encompassed within this code chunks. Okay, it's called chunk, soya chunks, code chunks, right? They're encompassed within these 3 backticks. Am I clear?
Yes, sir.
Okay. And anything in between is just text. Okay. For example, it says that, okay, this is a heading, second level heading, 2 hashes are there. This might be, sorry?
After this first 3 backticks, the stuff within the curly brackets, that seems to be different every time.
Yeah, I'll tell you that. Okay, just think about this being something like this. Okay, we'll come to that. There are multiple options you can have. You can have multiple outputs. You can have affiliations. You can have institutes, subtitles, multiple authors. All of that is possible, right? Just like that. The options of the code chunk can be anything. Okay. You can specify, that R can run Python code, that R can run Julia, C++, all of that. So any code chunk which is within these 3 backticks can be, like, for example, just pay attention here. I can press this green button here on top. There's a drop down menu here, insert new code chunk. When I press it here, it's going to ask me what code chunk do you want. I can say R, Bash, D3, Python, R, C++, SQL, Stan, or whatever. If I want Python, I can just press Python. So it's going to open a Python code chunk. How does it know it's Python? Because it's written Python here. How does this know that this language is R? Because R is written here. And there are other things also, right? You get my point?
Yes, sir.
So I can do 2 plus 2. 2 plus 2 or 2 plus 3, and I can just let me save this. A good practice to save your RMD files. When I say RMD, I mean R Markdown files, because they are not codes, right? They are your analysis. That is where you put your written thoughts along with your analysis together, right? It's where you prepare documents, right? You're looking at individual data and making tables is done. Now you have to bring all that together into a report, right? So this is where I usually put my analysis files. I'll just open analysis document and I'll say my first RMD. Okay. Now, if I, the way you bring all these things, there are three things in an RMD file. The first thing is a YAML. The second thing is a code chunk. The third thing is the general text that you write. Okay. This is a markdown document. Our markdown is a simple formatting syntax for authoring HTML, PDF, and Word documents. For more details, look at this. When you click the knit button, a document will be generated that includes both content as well as the output of any embedded code chunks within the document, not just R code chunks, even Python, we can see. You can embed an R code chunk like this by just saying that 3 backticks followed by 3 backticks and curly brackets and anything in between. Shortcut for adding a code chunk again is I'll just add a shortcut for adding code chunk is this button here, or it is Control Alt I. Sorry, yeah, I think it's for me. It's Control Alt I. Yeah, Control Alt I. It's disabled for me somehow. But yeah, I can just add this. Okay, I'm just showing. Now I can press this knit button. How many of you pressed the knit button before?
Haven't.
Okay. You can knit it. Once you knit it, it can ask you want to knit it as HTML, PDF, or Word. Right now we are using only HTML for now. The moment I knit it, it's saying that error in library in between lines 27 to 28. There is no package called tidyver. So how do I rectify this error?
Correct the typo. ID word.
Okay. This is the mistake that I have done.
So
I
when you were,
forgot. Sorry?
So when you are knitting, you got all these multiple options. So if we have only specified in the document as HTML, will we still be able to knit to PDF or will that be an error?
I'm knitting it to PDF now. It is processing the document. It is running an unnamed chunk too. So this is the unnamed chunk too. It's taking a little bit of time because it has to start Python on the back end. And it has created my first RMD document, PDF. I can go to files. I can go to analysis. My first RMD document. 2 plus 3 is 5.
So good.
Okay.
Yeah.
Okay. Now your question is, I want to create a Word file. Isn't it?
So then what is the point of us specifying the output format here in the file?
Yeah. Did I write anything here?
Mm,
Accepting.
This is the Word file. Everything is editable. Whatever you can type, whatever, right? All that is possible. I am not very good supporter of Word, so I will close it. But you are just giving options here. The moment you press something, it's automatically writing the code for you, right?
Yeah.
Okay. We can also knit with parameters. I don't want to go here, but you can specify that, okay, this is my DF. You create a report only for Rajasthan. Okay. You can specify your parameter to be Rajasthan, and the state equals to Rajasthan, and everywhere that filter, whatever, select, whatever, everything will be for Rajasthan. So you'll have a specialized report for Rajasthan. You can say parameterized report, do it for Bihar, and it will make it the report specifically for Bihar. You getting my point?
Yes.
Maybe if I show you this later on, you'll get and you'll understand it. But yeah, this is the first RMD that you have created. Now, what I want you to do is I'll be sending this code that we have worked today. Okay. Okay.
Okay.
And I'll also
Okay.
Yes, sir.
send this RMD document. Okay. Now it's up to you guys to figure out where code has to go and where the description of, see, for example, I'll just do a couple of things first, okay? So that maybe you will understand. I will remove all this for now. Okay. I'll remove even this also. Okay. And yeah, let this all be the same. Okay. So I will say that this is introduction. Okay. And I'm going to call this analysis of CAB survey data. You can add subtitle if you want. The data is coming from the okay. Introduction. The what I will do, I'll very quickly cheat. I will just go here. So I have some description about the CAB survey. Okay. So what it says is CAB survey is how many of you like working in Word?
Yes, I do.
We all like to work in Word. Okay, this is talking about the methodology of the data. Okay. Now, whatever it is. So we can say, then you can say literature, review of literature. Whatever you want to add, you can add. You can say,
Scenario.
yeah.
NS.
Okay. I'm just adding things so that then methods. I'm just adding some random text. Results. Okay. I'm knitting this. Then, so this is what is created. Okay. Okay.
Yes. Yes.
So this is the first level heading.
Yes, sir.
These are the second level headings and whatever. You can just add the text you want. For now, what I will do is this is a section on the ROL for the study. This subsection talks about the nationwide problem of and need for the PhD study. State-wise, this section talks about the power action group PhD states and their contribution to the CAB study. These restricts are whatever. Okay. Now I'll very quickly knit it, and you see all that is reflected here. Are you seeing it?
Yes. Yes.
Okay. So now this is the method section. This is usually what we do. Here we have written looking at. It would have been better if you would have written it properly, but I can just very quickly for the districts of whatever, I don't know. Yeah. See, these links are also clickable. You did not mention anything about how this has to happen, right? It has already created this for you, right? But anyway, study design sample size, I'm not going to touch. I would prefer that you all must have done one analysis, no? Something like this. You must have written introduction ROL, at least that much
Yes,
for
sir.
something. 2 paragraphs,
Yes.
3 paragraphs. I would request you to do the same thing in R Markdown and then see. Okay, talk about. Right. Okay, so this is where we start things, right? In the results part, you would add an R chunk, go here. These are the packages that you're loading. isn't it? And then you are loading the data. You know that you have 6 Excels. Let us load that 6 Excels. Sorry, CSVs. If you want, you can keep this, but I will not use that. And then I would do some cleaning, isn't it? And then I can say a very present, and then we can add a R chunk and then say DF glimpse. Okay. And then we can very quickly look at just the numbers I'm putting here. So I can, okay, right now I've loaded the data. If I just run, see the way I can run a chunk is I can just press this run button here. So the moment I run this, okay, in my environment, I have this data set available. Okay. Now I can look at this data. Okay. And now I want to count the urban and rural things. So if you remember, DF pipe count urban rural was the thing, no? Rural urban, no? This is one way we did it. We are planning to use the GT summary package, right? How did we do that using GT summary? How did we do that? DF 5 select rural underscore urban and then table underscore
TBS
summary, isn't it?
Yeah.
Now let me net it. See, baseline characteristics, library tidyverse, library here, GT summary, loading the data, very quick summary, looking at the variables present, GF glimpse, and then looking at numbers. This is how the output table was there using the GT summary package. This is how it is. Now the question is that I don't want, see, this is a report. It would have been okay if it is for me so that I can read the code and the results. But sometimes I don't want the code. I just want the output.
Oh.
Sometimes it happens, no?
Yes.
So for example, for this chunk, I only want the output, this table. I don't want this code. Okay. I can go to this gear button and say output, show output only, and press apply. The moment you press apply, if you remember what Lokesh has asked, there is echo equals to false that has come here. Okay. Now let me knit it. Just pay attention to this part of the file. And just knitting it. Now everything is being run once again. It is loading all the 6 data files, making it, all that is going to happen. Now, I asked you to pay attention here, right? That code chunk is no longer here. It's only the table. Okay?
Okay.
We can do the same
Yes.
marital status. Okay. Let us see how we can. Do you see?
Yes.
Okay. So yeah. Now for this one, I don't want all of this. Okay. In fact, for these chunks, I don't want anything to be showing only. I don't want all of this. I can say don't show anything, but run the code. Okay. I want you to load all the data sets, but don't show anything. Show nothing. And don't show the warnings also. Don't show messages also. Apply. Now I knit it. So it's starting from glimpse. This also we can remove. This whole chunk we can see. This one I don't want to run the code also. I don't want anything. Don't show anything. Apply. Okay. So now I would like to create a PDF. It's interesting now for 40,000 rows, it has done all the calculation and everything. It has already created the PDF and the PDF is here. Are you able to see?
Yes.
Okay. Here this table is printed with knitted table, not GT,
Yes, sir.
message equals to false. So we can just take this message equals to false and we can just put it in here, then knit it once again. See? Okay, this is still here. Oh, this to be here, no? Just bear with me. See, that error was gone, no? Okay. It automatically did everything for you. I can have your, can anybody just for my satisfaction, I would want you to help me create one ggplot.
Okay.
Yeah, I'll add R chunk. Okay. Yeah. I will call this. Yeah, let this be gender and hypertension. How do you want it? Or I'll give you an option. You can have any other plot that you want.
Gender and hypertension.
Okay, gender and hypertension. Great. Yeah, tell me. Come on, tell me.
The code or the description?
Code. What do you want to create?
Bar chart.
Okay, fine. That's fair enough. You want to create a bar chart? Okay. Now, you want gender in the x axis or the y axis? Sorry?
Sir, x-axis gender, hypertension in y-axis.
This won't work because ये करना था हमें, है ना? है ना? अभी तो ये तो मैं निकाल दूंगा. I don't want to. Okay, it says execution halted. Geom bar says Geom bar. What was this issue? Let us run this. Says that application cat not found. What was the variable name? हुआ तो. Okay, what's it saying? Stat count. Working. I think it's because the file size is a little big in terms of 40,000 rows, but it will work. Okay. One other good thing is that whenever things are not working, you can always close things and open once again. The previous R session is there. Here, my first RMD document. Admit it. Okay, it says okay. I think my PDF was open. That's why there's the error. Now it has created the PDF 10 p.m. This is the plot that you have. Yeah. This is not working properly because ideally what should have been, there is no X and Y axis in a bar plot, isn't it? It has to be X axis here. And color needs to be X, isn't it? And position equals to dodge. I think so. This is to be bar. Let us see if it's working.
The dodge is so that those labels don't overlap.
Sorry?
The position is equal to dodge.
Let's look at this. Fill equals to, no? Position equals to is actually position equals to dodge. Is that with bar? Call. Anyway, position dodge, right? Dodge to. Anyway, it's taking stack. I don't know why it's not taking dodge, but yeah. I think it has to be outside, no? Yeah, not within aesthetics. Sorry. This is what we wanted, right?
Yeah.
Okay. And now when we need this, it has created a PDF. This is that PDF. Okay, we can change things and all. But one other thing I wanted to very quickly show you is that you can add references. This is the section on you can add references very easily here. You can, there are two ways you can do it by. One is to manually add it. The other one is to go to the visual mode. The moment you go to the visual mode, you have this word like appearance, right? And then you can insert maybe a citation, and you have n number of things. You can go to your Zotero library as well. I have my Zotero library here. There are n number of things available here, but for example, I'll just add one of my articles and just say insert. Saving bibliography, and now I can knit it. Now the moment I knit it, it will automatically take in my references. So you have the citation added here, you have reference. Am I making sense?
Yes.
Have you anytime added reference in document?
Yes.
How have you done it?
At our college, they told us to use Mendeley.
Mendeley. Okay. Anand, what about you?
Same rule was applied.
Okay. Mendeley.
Yeah.
Okay. Anybody has used Zotero before?
Heard of it, but haven't used.
They mostly use
Google
Mendeley,
Docs.
sometimes Zotero.
Okay. Yeah, I would prefer that you shift to Zotero because Zotero is open source, and
Yes,
it
sir.
has a very interesting package called Zotero R. Okay. So if you have your corpus of all your citations, articles, everything, you can do bibliometric analysis using R as well. Okay.
Yeah.
Okay. Anyway, I will stop here for today. And any quick burning questions you can ask. The idea is that within a single document, you're creating all the things that you want, including figures, tables, citations, all of that. And you're not moving away from your RStudio window. Everything is here itself. Usually what we do is we open Excel, create a graph or a table, copy it, then take it to Paint or a Word, and then do the copy pasting and all of that. This single PDF document, you can also knit it as a Word file. I can very quickly say knit to Word, and it is going to do the same process again. And then it has created your document here, and this is your Word form. It's everything the same. Even the citations are there, references are there. Even if you have table numbers, all of that, it will automatically generate if you want. Table numbers, figures, table of contents, page numbers, annexures. You can write your thesis also here. Anyway,
Yeah.
so yeah, so this is a very quick, dirty introduction of R Markdown. I know this is not very helpful, but at least I wanted you to not be afraid of it when you hear about it later on. Okay, so
Yeah.
I would like to request you to go through the statistics part of things because we will not really go much further if we are this way. We would like you to get involved a little more, look at the theory behind all the tests that you're doing or whatever you have done, right? At least by the end of this month, you should be able to perform a couple of regression problems within R. Come up with an analysis, write a report. I'll be giving you a couple of data sets. You will have to analyze it, do a chi-square test, estimate odds ratios, relative risks, and things like that. Write your, interpretations and things, and all of that within R Markdown. Okay. Anand, for you,
Okay.
you can see what fits for you, but at least for Shruti, Suvarna, Parthi, location, predictor, I would insist that we stick to some epidemiological principles. Okay, just get a refresher. I'll send it
Yes.
link
Yes, sir.
or whatever.
Yeah.
Okay, then take care.
Thank you.
Okay.
Bye. Yeah.
Thanks.
Thank you, sir.